Bismillahirrahmanirrahim. Assalamu alaikum.
وعليكم السلام ورحمة الله.
عليكم السلام ورحمة الله.
عليكم السلام ورحمة الله.
So we are doing the chapter number 2, and chapter number 2 we are looking for approximation of the simple root of a nonlinear equation, and for that we have to do 4 numerical method. Inshallah we already finished, alhamdulillah, we finished the first numerical method, which was bisection method, and at the moment we are doing the second, one of the not best in the sense that it is converge fast, but it is very helpful for other method also, is called the fixed point method. And I told you the fixed point method, we are given f of x equal to 0, and we have to convert this f of x either in this form g of x minus x or x minus gx, same thing, right? And for one f you have more than million of g, but among them only one g will be the good one, which I give you the last time. The condition g must be good one is what? If g has, teacher say, show that this g has the fixed point inside the interval. So how can we say, which I mentioned you last time, g must be continuous in the interval, and the value of the g at end point of the interval must become inside the interval. This means at least one fixed point. And if g dash is less than 1, then it is 100% guarantee we have a unique fixed point inside the interval. And then you can use the formula, then you can use the error bound formula. And I think, or maybe you just let me know, I think we finished last time example number, this is the example we finished, example number 220. You are with me? Is that one we finish in?
Yes.
Yeah. Now, you have any question for this example or not? Is okay?
Yes.
Now, we move to the, go back and we do more example, interested example for this case here now. Before I give you the example here, I give you, this is one of the very best note of chapter number 2. And it is what? It is, assume gx and g dash are continuous function of x for some open interval I with a fixed point, alpha contained in the interval. Now, this is a condition. Please remember throughout the chapter, if g dash alpha in the absolute sense is less than 1, for every point inside alpha majud inside the interval, then it is 100% guarantee your method will converge. Method will converge. What is method mean? Is this one. This is a method you have. xn plus 1 equal to g of the xn. This is a fixed point. Please, this is not only for fixed point here. If you are given xn plus 1 equal to something, please remember that one. Something is always your what? Is g of xn. G of the xn. Now, if g dash alpha is less than 1, then it is 100% guarantee whatever the method we have here now, it must be converge. But if g dash alpha is greater than 1, then it is 100% guarantee the method will diverge. Diverge mean when you use the formula, all the jawab should not come inside the interval, which we don't want. And number 3 condition, if g dash alpha is equal to 0, then the method will converge very, very fast. And if g dash alpha equal to 1, then we have no guarantee method will be converge or maybe diverge. But if converge, it converge very, very, the slow we have here now. So this is very important note, please. We have to check lot of example. Before we solving, we have to check the method for this problem converge or diverge. If converge, slow or fast. So you can see when we say g dash alpha is less than 1, what is your range, please? Any student? If we say g dash alpha is less than 1, absolute sense.
0 and 1.
0 and 1, this is the things. 0 and 1. It's mean if the value of g dash is inside here, what does this mean? Always converge.
Converge.
If the value of g is outside, always mean
Diverge.
is a diverge. And about the end point, if the value of g dash is at this point is 0, it converge very, very fast. If the value of g dash at equal to 1, then we have no guarantee. Maybe converge, maybe not converge. If converge, it converge very, very slow. It's mean, what do you have the rule now? Your rule have now, as the value of g dash is going away from 0 toward 1, your method becomes slower and the slower here. This is very important, please. For every example coming in chapter number 2, we have to use this rule. Now, slow mean g dash alpha should not equal to 0. This means slow. Slow mean linear. And if g dash alpha equal to 0, it means converge very fast. And very fast, sometime I say quadratic. Method is quadratic. So when I say method is quadratic, what does that mean? That means your method converge very, very fast. And if I say method is linear, what does this mean? Method is linear mean it converge very slow. Okay. Now let's do some example. Now also, before I give you this example, can any student give me idea? How can we find gx, please? Remember I told you how can we find gx?
We take x on one side.
F of x. This is always given, right? This is
Yes.
equal to what? Right? This is a way we can find gx from f. And this is equal to what?
0.
0. It means x is equal to what? This is the way we have find the g. And when you find the g, what you need, please, always to find g, what you need? F of x must be
Given.
given, then you can find g, otherwise no. Now, let's I say go opposite. Gx is given. Can I find f?
Yes.
How can we find f?
X minus gx.
Yes, x minus gx. This is a way we can have here now to find it. Because in many example, also I will give you what? I will give you g and I say find f. For one f, you can have million of g. For one g, how many f you can find?
1.
Only one. Only one g f we can find out here. I give this example. I say the expression, this is the formula, is an iterative formula to find the root of f of x is equal to 0. What is your f of x here? So what is this one?
G of x.
This is your g of x here. So only things you have to do what? You have to do?
Put it on the other side.
Yeah, put x minus gx. And when you simplify after taking LCM, You have 5x because you have 5 in the maqam. So you can have here now. Or you can, if you are very clever, what does this mean? This means x is equal to what? I'm right?
Yes.
Yes.
What is your gx? 2x power
Square.
2,
square plus
3
3
over 5.
over 5, right? Cross multiply. 5 multiply by here, cross. What you have?
5x.
Equal to
2x square plus 3.
plus 3. And how can you find f? You take all that from one side, make one side equal to
0.
0.
that's you have here now. 2x square minus
2.
5x plus this is equal to,
0.
and this is your f of
X.
x. So that's mean if you can have f, you can find g, but you don't have to find g. G always given from the teacher. But if teacher give you g, he will never give you f, and he say find f of x. This is a way you can find f of x here, right? That's the jawab I give here, to find f of x, and this is f of x. We exactly the same thing we have here now. Let's come to the good example now. Here, this is the theorem I give you here now. This example also we'll do later. This is the things we have here now. This is many times I give this example in the exam, please. Yes. Now, he say, convert the non-linear equation to the fixed point formula, x is equal to this. This is what, please?
G of x.
G of x. With the condition k is a non-zero constant. This is the first part. That means you have to find g, and then when you have the g, then you can write the formula, because xn plus 1 always equal to g of xn here. Right? This is the formula. He say develop the formula for this function, the fixed point formula convert. So that's we got. This is the first part. Second part say, after finding the formula, find the value of k, which give you the condition that this formula will converge very fast. Ensure rapid convergence. Rapid mean very fast. So what does that mean? G dash must be equal to
0.
0. This is the condition I give you here now. Now it's a very simple one. What you are given? You are given x square minus 5. I'm right?
Yes.
And I want to find from this, I want to find this one. I multiply both sides by k, because k is a non-zero constant. I multiply both sides by k, so we have k x square minus 5. K multiplied by 0 is a 0. Then what I did, I subtract minus x and plus x. This is the same thing. Minus x plus x is what? Is a 0.
0.
So plus k equal to 0. We have this. Then I take this minus x on the other side. And minus x on the other side become positive x, which we have is x equal to x plus kx square, which I give you exactly the same thing. After finding this g, then put into the formula shape like this one. So we finish this part. The second part, he say, find the value of k with the condition that this formula converge very fast. That means g dash alpha should be equal to
0.
So you can have g. This is your g, right? You take the derivative. What is the derivative of this one, please? What is the derivative of g?
1 plus
1
2
plus 2kx.
2kx.
Finish, right? The derivative of this one is 1 plus 2k
X.
x. So in place of x, you have to put alpha. So g dash alpha equal to what? Square root 5, because this is equal to 1 plus 2k x square root 5. And this should be equal to
0.
because why 0? Because teacher give you the condition is the method converge very fast. And then you put equal to 0. When you simplify, inshallah, you have this thing. When you simplify, and what is this one? K, you take 1 on the other side, it become -1. And this 2 root 5 will come in the maqam. And that's the jawab of the problem. Last time I gave this example in the exam. I say, find the value of k, which I give, which is I solve in the book here now. Then I give one more question here after that one. And what is that one? I say, I give this one here. I say, if x naught equal to 2, compute absolute error. E alpha minus x2. This is I add this question in the exam here. It's very simple. What you do to
Check
compute
it.
to compute this one, what you need? Alpha.
And x.
Alpha is given, right? Root 5. You need what?
x2.
X2. How can you find x2? From this formula. What is x1?
G of x0.
Yes, g of x0, which is what? Plus k x naught power 2 minus
5.
5. What is x naught? Given by the teacher. 2. What is k? You just calculate here. Right? And then you can have the value of x1. And the same way you can do what? You find x2. Last night I finished because I changed this. This is the old version of my book. I make a new version of the book last night and I put this example together, this x2 here. And inshallah, last night I finished and I will send you today the chapter number 0 and this half of the chapter of number 2 first, then half later on. Half of the chapter 2 I will send you inshallah today. And this is a new version, not this one, right? This is the old version we have here now. Is okay now? You understand this example, please?
Yes, inshallah.
Yeah. Then this is also 2-3 times I give the problem in the exam. This is exactly the same like this one, the previous example. In place of f of x is what? I have this one. And then I say, convert this fx into this form. So very simple, same way you can, how can you add like this one? You will see inshallah. And then you can find out. Then he say compute the third iterates, third approximation starting with this one. After you're finding the value of C with the condition he given again. He say find the value of C. There I use K, here I use C to ensure the rapid convergence. That means this is what? Is a G. Take the derivative of this one, put equal to 0. You can have the value of C. And when you have the value of C is this one. And then you use the formula x1, x2, and x3. And you can have, this is the jawab we have here. Exactly the same example like this one. 2.13, leave that one here. Now this is another example, is a very good one here. This is also I gave 2-3 times in the exam here. I say show that the fixed point form of this non-linear equation, this is this equation. I never say non-linear. You have to make it non-linear. show that the fixed point form of this equation can be written as this one. So this is what? What is this one, please?
G of x.
G of x. That means you have to find G. And how can you find G? Always you need what?
F of x.
F. So can you give me what is F you have for this case? I have, let's say, you can see that. What is your F?
X cube minus n.
Yes, because I told you I give the example number 2.6 last time for the bisection method. This is you have here. Now you have to make this a non-linear equation. So what you have to do, take the power 3 on both sides. So when you take the power 3 on both sides, what you have? X cube equal to n. Then you take n on this side. This is the things we have here. X cube equal to n, then take n. This is your f of x. Then he say, after you have the f of x, then he say, convert your f into n. So very simple. What is your f? This is the shape of f. Then you can write x cube is what? X into x square, right? Same thing, equal to n. Then you take x only on the left hand side, x square you take in the maqam. And when you take in the maqam, take on the plus. And when you take on the positive, power is negative. And this is the same thing we have here. And this is the fixed point formula. Then second part of this question is what? He say, this formula is not good, is not successful. Not successful mean diverge, not converge. What do you mean by diverge, please? I give you the condition today.
The derivative is equal to 1.
Yes, derivative we have to make it. What is the derivative of g? Derivative of g, we can easily, I said, derivative of g is what? Minus 2n x power minus 3, right? And take the derivative at alpha is minus 2n alpha. What is your alpha given? What is alpha?
It is not given.
Or given. X always mean what?
Alpha.
Alpha. So this is your alpha. N power 1 by 3.
1 by 3.
So you can put here g dash alpha equal to this one. In place of alpha is n power 1 by 3. Then you have n and n 1 by 3. 3 cancel. You have n power minus 1. N into n power minus 1 is what?
1.
1. So minus 2. Then you take absolute sense, because we say g dash alpha in absolute sense is greater than 1. We say that. So it is 2. We show this formula, this g is not good one. This g is not good. Now, this example also I give many times here now. I say, I give this example also, not last semester, before that one. I say, which of the following sequences converge faster to this one? Well, when I give the first time in the exam, you know the students are very clever, but in the opposite direction, not in the right direction. Teacher can make mistake. I make mistake, small mistake. I give the problem in exam. I say, which of the following sequence converge faster to this one? Some student, because my question is like this one. Some students say number 1 is converge faster. Some students say number 2 is faster. In 1 second, the answer. And of course, they are right, because I only say which one converge. Then I say, next time when I give in the exam, I say, which following sequence will converge faster to 5 and y? And y is converge faster. So how can you say converge faster, please?
The derivative equals 0.
No, derivative equal to 0 mean very, very fast, right? When you compare this one, I told you, if the derivative of g is going away from 0 toward 1, it become
Slower.
slower. So it's mean you have to take the derivative of this one and the derivative of this one at the alpha root 5 and then check which give you the smaller value. So what is G1? G1 is your what? X plus 1 minus x square by 5. We have this one, G. I take the derivative of this one, which is 1 minus 2x taken by 5. Check the derivative of alpha, which is this one, which is a 0.1056, which is, of course, should be less than. Teacher already say converge. What is your second? G. This is your second G, which I say G2. And we can have here now, I take the derivative, which is the derivative of this one is this. And then I take, and we have 0.7. 0.7 always also converge. Now, we note both sequence converge to this one, but the sequence first one converge faster than the second one. Why? Because G-1 is closer to 0 as compared to that's G2. And also, when I gave in this problem in the exam, I say same thing. I say, give in the exam, I not ask which one is converged faster. The third time when I give in the problem in the exam, I say use faster sequence or formula, same thing. Use faster sequence to find alpha minus x2, right? x2 by using x naught is equal to 2.5. So it's mean what you have to do. You have to check first which one is
faster.
Is the faster, and then you will find which one is faster. This one is the faster, right?
Yes.
Because this will give you, and then you find out the second approximation. What is your first approximation? X1 equal to what? X naught plus 1 minus x naught squared 16 by 5. So you know x naught. You can easily find out x1, and the same way you can find x2. And I also change this one, and I put the new version, which I will inshallah send you today. This is also, I give there in the exam, this example. I say assume that the iterative scheme generated by this sequence both converge. But they converge, they have the same function. This one and this one has the same function, because this function has, I just find out 2G. One is this one and other is this one. And how many root I have this one?
2.
2. And I say these are the 2G for this one, but both G converge to the different root, not same root, because it has a 2 root. For one root, one converge, for other root, the other. Now, okay, show that they converge different root of the same equation. Find the third approximation to the root 1 using suitable iterative scheme. Now, the root, it means one of the root is what?
1.
Is a 1. And you can see what you can make tahleel of this one. What is the tahleel of this one? Please, anyone?
X minus 2 and x minus 1.
So you have 1 and 2, right?
Yes.
So we have to check which one is converged here. Now let's I find out here, as I told you, you have alpha square. Alpha mean x square minus 3 alpha plus 2, which is the same. We show it. For this is your function. And this one has a 2 root here, 1 and 2 here. And then you find out what g dash. What is the g dash, please? What
2
is g dash?
over 3x.
2 over 3,
X.
right? And now you have to check 2 over 3x at the root 1 and 2. So when I put 1, what is the jawab? 2 over
2 over 3.
which is less than
1.
But when we check at 2, what is the jawab?
4 over 3.
And 4 over 3 is what?
Larger than 1.
Is a gray diverge. So it's mean one root, this is converge, and other root, this is diverge. Now let's do the second sequence. Second sequence, when you simplify x is equal to 3 minus 2 over x, you see, you find f of x. I told you how to find fx. And then you have the same thing again. Now you have to take the derivative. What is the derivative of this one? 0 minus derivative of 2 over x is what? Is minus 2 over x square. So minus minus positive. So we have this one. Check the derivative at 2 and 1. At 2, what is the jawab?
At 2, it's 1. No, it's half. Sorry.
Is a half. And at 1 is what?
2.
2, which is greater than 1. So it's mean this sequence converge to 1 and this sequence converge to
2.
2. Yeah. So it's mean the question is say use such sequence which converge to 1.
1.
So it means we have to use this formula to find the third approximation. That's I did here now, please. I find out x1 is equal to what? g1 xn. And what is g1? Which is I give you here. Agree? Good, good, good. And this is also the same thing I gave here. This is the 2 scheme. Which iteration will converge faster to this one? So you have to check after finding the derivative and which one is close to 0, you say faster here. Yeah, this is also I give many times this one here. Okay, this is good example, very good example, please. I say alpha and alpha 2 are two fixed point of the function, this one. My question is what? Alpha 1 and alpha 2, these are the fixed point. What does fixed point mean? G of alpha 1 should be equal to?
Alpha 2.
Allahu Akbar, G of alpha 1.
0.
Allahu Akbar.
Alpha 1.
Huh?
G of alpha 1 equal alpha 1.
Yes, G of alpha 1 equal to alpha 1. What does the fixed point mean? Fixed point mean a such point when we put in the G, the jawab is the same point. So it's mean G of alpha 1 should be equal to alpha 1, G of alpha 2 equal to alpha 2. Now, this is the first part. Let's say before I go to the second part, how can you find this one, please? How can you find out? Because we have to try head and tail, right? We have to put some number, and if the jawab is same number, then we say this is alpha, right? Then we check another number. It will take more time here. What is the easiest one? Convert your G into what?
Into F.
In F. And when you convert into F, the problem becomes very simple because Fu is a quadratic equation. You use the tahleel of this one and 1.5 here now. So what I did, because alpha for G, alpha 1 and alpha 2 for G and F, I told you exactly the same. So what I do, I use alpha equal to gx minus x, gx minus x or x minus gx. Same thing, please. Don't be confused here. Either you put x minus g or g minus x is same. Can you give me, what is your, this one now? What is your f for this case? 0.5
half x square
x square minus
minus half x plus 3.
2.5,
1.5.
right?
1.5.
2.5. I'm a
2.5,
teacher.
yes.
I'm a teacher. I say whatever say, agree.
Why it's 2.5?
Because I'm a teacher, I can put whatever I want. No, it's this one. You have 1.5,
Okay.
right? This is 1.5. And x also majud, so minus x. Okay, now let's see. Properly, let's do the proper way now. We have x minus 0.5 x square, right?
Yes.
Plus 1.5 minus, agree, because x minus g is your this one, and outside the g is what? Minus.
Minus.
So minus make this one negative, make this one positive, make this one negative, right? Which is this one. And this is equal to what?
0.
Always. So we can write here 0.5 x square. I'm right? I take, because it's always is a good idea, the highest power is positive here, right? So I take this one on the other side. Whole equation I take on the other side, because the other side is a 0. So what is this one? X plus 1.5x. How much is?
Half. Minus half.
2.5.
Two.
Oh. Yes.
2.5
2.5.
x and plus
Minus.
no plus, please. When you take minus on the other side,
Plus, yes.
so this is, and this is equal to 0. Can you make the halil of this one? Okay, simplify your. Multiply both sides by 2. Multiply both sides by 2. What you have?
X squared.
X square minus
Minus
5x
3. Minus 5. Plus 4.
plus
What is the halil?
minus 4.
minus 1 and minus 4.
All right.
Yes.
So how many root we have?
2 roots.
4.
4.
And this is the root you have here. Now you can, if you want to check, this is the root for f, but root for f also fixed point for g. Can you check here, please? You put 1 here. When you put 1 here, what is the jawab? 0.5 minus 1.5 plus 2. How much?
1.
1. So same thing, g1 is equal to, and when you put 4, inshallah, you will get the same thing we have here. Now, this is the things I give you here. This give you x is equal to 1 and 4, and g1 equal to 1. You can check g4 equal to 4. This is correct. Yes, 1 and 4 are the fixed point. Now, the second part, he says, for which fixed point this method will converge. So how can you check converge? You take the derivative of g and check the derivative of g at 1 and
4.
4. If less than 1, it is converge. Greater than 1 is diverge. So when you find g dash, what is the derivative of this one? Derivative of this one is x minus 1.5, right? Because derivative 2x, and 2 multiplied by 0.5 is a 1. So it's x minus 1.5 is the derivative. Check derivative at 1. It is 1. 1.5 is a 0.5 less than 1. And check at the other root 4. 4 minus 1, 0.5 is equal to 2, which is greater than 1. So it's mean this one has 2 fixed point. 1 and 4, but this method converge only at alpha 1,
One.
which is 1. And I add, when I give this problem in the exam, and I say find the absolute error by using x2, the same thing. Here I can give you the value. This I will show you, inshallah, in the coming revise my lecture. And this example already I solve for you here. This is called the fixed point method. I give you, well, if you have the other teacher always give you one example or two and they're finished. I gave many examples that you should understand the idea here now. This is called the second numerical method to find out the approximation of the simple root. We finish bisection method. We finish the fixed point, the method, and we do the third, one of the best method we have for that case. It is called Newton method. This is one of the best method, but remember that one, if we say something is best, best always slightly difficult, not difficult, because I told you, if you want something good, good needs some difficulty. If you want bad, bad is very easy. No need to spend anything, and inshallah you will get the bad things. But you want to buy the good thing, you have to spend a lot of things, right? A lot of money for that one here. So if you want to best method, you have to work slightly more than the easiest method, as we did in the case of the bisection method and the Newton method and the fixed point method. Now, before I give you this, I give you some general idea about the Newton method. As I told you, Newton method is one of the best method for the simple root. This is a good point. And Newton method it is an iterative method again. An iterative method always need initial approximation, and Newton method need only one initial approximation to start, which we call x naught. What about the convergence? Newton method converges very fast. This is a good point. But the bad point of the Newton method is what? There is no guarantee. Maybe converge, maybe diverge. Bisection was what? Bisection was always converge, but very slow. But Newton is very fast, but no guarantee. Maybe converge, maybe that diverge. And what is the formula of Newton formula? This is the Newton formula we have, please. Newton formula is what? Xn plus 1 equal to xn minus f of xn taqseem by f dash. So you can see here in the Newton formula, we not only need f of x, we also need what?
F dash.
F dash here. And to find the derivative is not an easy job here. And when you find f dash and you have something in the maqam, you must be careful if you have something in the maqam, because we always want maqam should never equal to 0. It means the derivative should not be 0. So why I say this method may converge, may diverge? Depends.
Derivative
The
zero.
derivative, because we have million of the problem, derivative does not exist. And when derivative does not exist, of course, we cannot use the Newton method. Sometimes derivative exists. And if derivative exists and the jawab is 0, again the problem. We want what? Derivative exists and should not be equal to 0. Then Newton is one of the best formula for the approximation of the simple root we have here now. Let's I give you a very simple example, then we continue. Of course, this example will not come in the exam. This is very simple one here. But remember this example I give you in the case of bisection, in the case of fixed point also. I use the same example, and we need this example x cube equal to this one, then that is located in the interval accurate to this one. Initial approximation is this one. So what you have now, This is your f of x. You find it, take all the from one side, make one side equal to 0. And then you have to take the first derivative. What is the derivative? X cubed minus 2. And then you can have here now the value of the function at 1.5 is minus this. Value of the function, derivative of the function is this. This is good. This is not equal to 0. It means we are ready to use the Newton formula because derivative is not equal to 0. When you use this formula, you have 1.63, this one. And then you have 1, and the same way you can find out the second approximation or this one. Then I just give you here, after I find the third approximation, my accuracy is what? 10 minus this 7 we have here now. Up to now, remember I give you what? I say this x cubed plus 2x plus 1 has a 1 root inside the interval, right? But I never give you what is the interval, what is the alpha. We don't need. Now I give here now, what is that root? This is the exact value of the root, 1.61. This is the exact solution. Why I give you this one? Because I want to compare your jawab with this one. So you can see this approximation, this is exact, and you take the difference, it is 10 minus 7. So you can see Newton method converges very, very fast. Just after 3 iteration, we get accuracy 10 minus 7. If you remember example number 2, one same example with the bisection, we took the 10 minus 2 accuracy, but we took how many? We took the 6th iteration. Here we only, if we did the 3 iteration, we get the accuracy 10 minus the 7 we have here. Because to get accuracy by 10 minus 2 by 10 minus 2 accuracy, we need only 1 iteration. Only 1 iteration. You see the function value is 0.01, which is 10 minus 2 accuracy we have here now. That is the good point of this one, but it is not very easy formula. We have to calculate f and f dash, and then we have to check. After we know f dash, we have to check f dash should not be equal to 0 at any initial approximation we have here. That's I give the third iteration. Value of the function is coming. How much small is very value? Okay, you can see here.
Almost 0.
Almost 0 we have here. Just after the third iteration. That's the beauty of the Newton method. But this beauty only for simple root. You remember I told you we will discuss 2 root, simple and multiple. For multiple root, Newton method is just like bisection. Newton method very, very slow for multiple. But Newton method only good for the simple root we have here now. No need for this error formula. Of course, this example now, I give you very, very good example. Many example I will give you here. This is one of the best example for the Newton case. I give you 6, 7 example, very good one. Inshallah, any one of them guarantee will come in the exam. And that will continue, inshallah, next time. Inshallah, as I mentioned you, please, I will send you today the revised version of that one here. Any question you have, please?
Thank you.
Also, I will send you, you have only one midterm exam, which I will see your face only in the midterm exam. And it is in the I think, it is in the 10th week, I think, in sometime in March. I will, inshallah, today also I will send you the syllabus. You have one midterm exam coming here, face to face in the Jamia. We will see, inshallah, each other. But before the midterm exam, we have one quiz, and that quiz will be online, right? It will be after 6 weeks. We are in the 2nd week now, right? In
Yes.
the sixth,
Yes, doctor.
yeah, so in the 6th week will be the first quiz for the 10 marks. And in the 13th week, you have the second quiz. It is also on the line. It has 10 marks, so 20. And your midterm exam, only one midterm exam from 30 marks. So it's become 50. 10 marks for the Tamareen. It becomes 60. And 40 for the final we have here. I will set all information, inshallah, too. See you then, inshallah. Take the attendance now. Yes. Number 1.
Yes, doctor. عيسى مطوع.
Right. Number 2.
سعد العمر.
Yes. Number 3. Number 4. Number 5.
يس محمد.
Number 6.
يس محمد القحطاني.
Number 7. Number 8.
زياد.
Number 9.
يس دكتور أسامة.
Number 10.
حسام السين.
Number 10. Hassan?
يس حسام.
Yes. Number 11.
يس دكتور.
Number 12.
مشاري عبد المحسن.
Number 13.
زايد المطيري.
Number 14.
فهد الحيدان.
Yes. Number 15.
عبد الله العمر.
Number 16.
بندر العيدان.
17.
عمر نهابي.
18. 19. 20.
محمد الخيبان.
21.
الأستاذ.
22. Hadi. No. 23. 24.
سلمان.
Yeah, 25. 26.
يس محمد العمر.
27.
سام.
28.
بالعزيز العنزي.
29.
نايف السويري.
30.
وائل الشهري.
31.
الوليد الخميس.
Yes. 32.
Yes, عبد الله سعد.
33.
يس ناصر عبد الرحمن.
34.
يس الحربي.
35.
يس سلطان.
36.
أسامة المسند.
37.
مشاري.
38.
طارم طيري.
38 Sultan.
ايوه.
39.
عبد الرحمن التركي.
40.
يس عبد المحسن.
41. 42.
يس محمد البراك.
43. Khalid.
خالد دكتور.
Yes.
خالد الأسامي.
Yes, yes. I told you last time 43, you are 43. Finish everyone?
هاي دكتور.
نمبر 3.
How many years?
Number?
3.
Number 3. Who's the number 3 with me? Number
Abdullah.
3. Oh, right. Who's the new student?
مين دكتور؟ مهند أبو عساف.
You are 44, please. I will inshallah print the new one. Okay?
Okay.
Then I will send you. But just up to now, this week, 44.
Okay.
دكتور.
Yes.
Is my number 43 خالد الأسامي?
Yes.
Or it change?
No, no, 43. I will now, next time I will print, inshallah, I will send you. Then we will take
Okay.
that.
Okay, thank you.
No, no,
دكتور.
43.
22 دكتور.
22. Hadi,
Yes.
finish.
دكتور I'm a new student.
Yes, 45.
Okay.
Okay. I will inshallah print, then I will do. Okay.
Okay.
Right, finish. We'll meet inshallah. As I told you, your first midterm exam will be 23 of March. 23 of March from 7 o'clock to 9 o'clock, 2-hour exam in the evening time, Tuesday. But I will mention you, inshallah. Don't worry.
inshallah.
Okay.
شكرا دكتور.
See you then, inshallah. Any question, please ask me any problem you have through email or whatever you have. Don't be hesitate, please. Okay, see you then.